So in this video, we're going to be looking at the integral of 1 over x cubed plus 1. And our first step is going to be splitting this into partial fractions. But to do that, first we need to factor the denominator here. So if we set x cubed plus 1 equal to 0, we can obviously see that x equals minus 1 is going to be a solution. So by the factor theorem, we can write that as x plus 1 as a factor. And using the sum of two cubes factoring formula, we see that it's x squared minus x plus 1. Or you could do this by long division as well. Writing this then as 1 over x cubed plus 1 equals a over x plus 1 plus bx plus c, as this is an irreducible quadratic. And we cross multiply everything, so we see that 1 is equal to a multiplied by everything here, so ax squared minus ax plus a, and then x plus 1 times bx plus c. So multiplying by the bx plus c first, we have plus bx squared plus bx, and then by the c we have plus cx plus c. And we're going to set up a system of linear equations to solve for a, b, and c. So looking at the coefficients of x squared, we see there's 0 on the left hand side, and there's just an a and b over here. And this then implies that a is equal to negative b. Looking at coefficients of x then, we see that 0 is equal to minus a plus b plus c. And this then implies, as a was negative b, this means b is going to be negative a, that 2b plus c is equal to 0, or in other words, c is equal to negative 2b. And looking at constants then, or x to the 0, we see that 1 is equal to a plus c, and we saw that a is negative b, c is negative 2b, equals 1, so negative 3b equals 1, and this then implies b equals minus 1/3, which also means then that c is equal to 2/3 and a is equal to 1/3. So we can write 1 over x cubed differently then, but just plugging it straight back into the integral, we called it, is the integral of dx, or I should, hold on, so that's going to be 1/3 by x plus 1 plus b was minus 1/3 x plus 2/3 over x squared minus x plus 1 dx. Now we can factorize out a third outside the integral sign and say we have 1/3 integral of 1 over x plus 1, and we're going to bring that minus sign down just to tidy it up a bit. So we've got x minus 2 over x squared minus x plus 1 dx. Now, this first bit is obviously simple, it's just going to be a natural log integral, but this bit here, we need to somehow make the numerator the derivative of the denominator. And to do that, the derivative of x squared minus x plus 1 is just going to be 2x minus 1. So all we need to do to sort out this first term here is multiply by 2. So to do that, we're going to split our integral up into two separate integrals. So we're going to have 1/3 integral of dx by x plus 1, and then we're going to have a minus 1/3, and we're going to multiply this here by 2, but to make it so that the integral is the same result, we need to multiply by a half additionally. So we're going to bring that outside the integral, so that's going to be times a half integral of 2x minus 4 by x squared minus x plus 1. Now, we're just going to say I is equal to 1/3 log x plus 1 as the above, and we're just going to say plus j, and we're going to deal with this separate j integral now. So j then is going to be minus a sixth 2x minus 4 x squared minus x plus 1. Now, again, as I said, differentiate the, oh dear, we didn't differentiate the denominator here, and we get 2x minus 1. And what we can do is we can split that 2x minus 4 up, that we can split that minus 4 up into minus 4 is equal to minus 1 minus 3. So we can say that that's going to be a sixth of the integral of 2x minus 1 minus 3 x squared minus x plus 1. And then we can split this up again. So we can say minus 1/6 integral of 2x minus 1. It makes things nice and easy for us. And we can have another integral where we have minus a sixth integral of minus 3 by x squared minus x plus 1. Now bringing that out, the minus 3 here, obviously minus 3 times 6 is going to be half. But to solve that, that's just going to be a classic arctan integral, so we need to complete the square. So x squared minus x plus 1, x minus a half squared, and then this is going to be plus root 3 by 2 squared. And then what we can do is look at the normal integral formula of x squared plus a squared, and that's just going to be 1 over a inverse tan of x by a, and obviously plus c. So here our x value is x minus a half, and a is root 3 by 2. So, and then this obviously is dealt with now because it's just a log integral. So what we do is we say this is equal to minus 1/6 log x squared minus x plus 1. And then what we're going to do is plus a half times 1 over a, which is root 3 over 2, so that's just going to be 2 by root 3 inverse tan of x, which is x minus a half, over a, so root 3 over 2. Obviously plus c, but we'll omit that for now. So then we can combine that with I, and we say I is equal to 1/3 log x plus 1 minus a sixth log x squared minus x plus 1 plus 2's cancel, and we get root 3 by 3 when we rationalise. And in the argument here, what we're going to do is just multiply everything by 2, just tidy it up. So you get 2x minus 1 by root 3 plus c. And that is our answer, but we can simplify this a bit further. So 1/6 can be written as a third multiplied by a half. And by our log rules, we can bring that half up here and make that root x squared minus x plus 1. So what we can say then is I is equal to 1/3 log x plus 1 minus 1/3 log root x squared minus x plus 1 plus root 3 by 3 tan, inverse tan, 2x minus 1 by root 3. And then we can factor out a third term, and we can simplify the two logs by making them into one argument, just with log laws, So we've got 1/3 on the outside, log of x plus 1 by root x squared minus x plus 1, and then plus root 3 inverse tan of 2x minus 1 by root 3 plus c. And that is then going to be your answer.